So, today we're going to talk a little bit about finding quadratic equations and using different sets of points to do that. The warm-up that you'll have today was about finding a quadratic equation, but it was with two specific things. It gave you a vertex and a point. All right. And what you'll find is that this is actually the only way to find a complete quadratic equation with only 2 points. You have to have a vertex in order to find a quadratic equation with only 2 points. The reason behind that is that vertex is that middle part of the parabola, right? And if we have a point, we actually know that there's another point exactly opposite it on the parabola. It takes 3 points to make a parabola. Any 3 points can define a parabola, but you need 3 of them. Does that make sense? It's like if we're trying to draw a triangle, we need 3 lines. With a parabola, we need 3 points in order to draw that parabola in. Now, we can do it with any 3 points, but we're not going to learn that today. That's going to be something that you learn in Algebra 2. What we're going to learn is one more specific case where we can find a parabola given just special points. We can find a parabola if we have 2 zeros and a point. 2 zeros and a point are enough to find a parabola. I'm about to unplug Joe's laptop because I'm not going to trip over it again. Sorry. Does that make a little bit of sense to everybody? 2 zeros and a point. Now, why are 2 zeros and a point special? Well, if we think back to some of the things that we've done, where we talked about looking at a graph and determining those zeros, let's say that we've got a 0 right here at, let's call that -4. And then we've got a 0 right here at +3. And then I just give you another random point. It doesn't matter where that point is. It can be anywhere. So let's just pick this point right here. And let's call that point 5, 3. Not a perfectly proportional picture, but we've got 3 points. We've got 2 zeros and a point. Now what we can do with the zeros of a quadratic function is we can actually use them to determine a factor of that function. All right, so when we're looking at factors, we can look at this one, -4. What that actually translates to as a factor is going to be, and remember, x always does the opposite of what you think it does. This is going to be x plus 4, and then this is going to be x minus 3. And what I actually want y'all to do right now, go on Desmos, go on something, find some sort of graphing calculator, and plug this into the graphing calculator equation. I want to see what you get.
Exactly like that.
Exactly like that. So I see that a couple of you have it plugged in. I'll give you just a few more minutes to make sure everybody has it plugged in. So now that you've got it plugged in, does that parabola give you an equation with a 0 at -4 and a 0 at +3? Yes. So that makes sense. We can take our zeros and turn them into these, which then turn into a parabola. What's the problem with that parabola, though? Does it have a point at 5, 3? No. So it turns out there's one more thing that we have to incorporate into this to find that last thing. And this is where I'm going to go back to that warm-up, because remember, there was an A. There's going to be an A here as well. It's the exact same A. It's the exact same thing. So this is y equals A times x minus 4 times x minus 3. So this is just a matter of taking this now, plugging in our point, and solving for A. So I'll plug in our point. 5, 3, x is 5, 3 is y. So I get that 3 is equal to A times 5 plus 4 times 5 minus 3. 5 plus 4 is 9. 5 minus 3 is 2. And then we've got A, and then 3 equals. 9 times 2 is 18. So 18A is equal to 3. Divide each side by 18. And we get that A is equal to 3 over 18, or we can reduce that to 1 over 6. Yes. Yes, in a moment. So we get that A is equal to 1 over 6. So now let's go back over here to our equation. Y is equal to 1/6 x plus 4 times x minus 3. So really, the only difference between the vertex and a point that we did as a warm-up and this 2 zeros as a point is that you just have to know how to make the 2 zeros into a quadratic equation. And really, that's as simple as this. This is all you have to do to make that into a quadratic equation. Sometimes you'll have hairier numbers. Sometimes you'll have numbers that are harder to work with. And when we're talking about real life situations, all the times you're going to have numbers that are harder to work with. So in your problem that you're working on right now, you'll use those numbers, you'll use those zeros, but you should still be able to get a quadratic equation that will give you that information. Does anyone have any questions on this?
No, sir.
All right, so at this point, I think that you've got everything that you need in order to solve that problem, all the questions on that problem. So I'm going to give you time, get that taken care of. First thing next class, we will be presenting. So be ready for that. All right?